Okay, today we are going to learn about the power series solutions of linear differential equations. The power series solution is kind of the method that we are using to find a solution for linear differential equation which has the variable coefficient. Previously, whatever we learned how to find the solution of differential equations, those differential equations always have the constant coefficient, right? Except for the Cauchy-Euler equation that we have x to the power n or x to the power something as a coefficient of the differentiative terms of y. So now what if we don't have the constant coefficient? How can we find the solution of that type of differential equation? The way that we can do is just using the power series method. Okay. Let me give you an example of the linear differential equation with variable coefficients, such as Bessel equation. The form of Bessel equation is happen this way. The Legendre equation where p is just a number. So if p is equal to when you arrange the form into this term, then we call it the Legendre equation. Okay? So the way that we find the answer of this type of equation, or another word that we call just called the differential equation with variable coefficients. You see, you have x squared here, you have x there, and then you have x squared here. P could be any number like 0, 1, 2, 3, or 4. This depends on the equation itself. Okay. So to find the answer of this type of differential equation, the way that we can do is just that we assume y is equal to summation n equal to 0 to infinity an x minus x0 to the power n. So and x0 could be any number. It's just it's kind of we are looking for the solution around that point, x0 point, something like that. Okay. And when you take a look at this, it comes as a summation of this one is called power series. And before we go further to the method of finding solution, what you should know is just that what if we have this type of function, what would be the power series form of that function? That is the thing that you should know. For example, we know that if we have the function like this function, if you write down in the term of power series, it's b in this one. This is just the form, okay? If you have exponential of x, you can write exponential of x in the term of power series as this. The summation of x to the power n divided by n factorial where n is equal to 0 to infinity. Or if you write down as the power series form, you would get 1 plus You put n equal to 0 there, you've got x to the power 0, which is equal to 1, plus x to the power 1 divided by n factorial, which is equal to 1, plus put n equal to 2 there, you would get x to the power 2 divided by 2 factorial, which is 2. X to the power 3 divided by 3 factorial, and so on. If you have cos x, if you write down the term of the power series, you would get summation n equal to 0 to infinity of the function minus 1 to the power n times x to the power 2n divided by 2n factorial. If you expand this term, the way that we do it is put n equal to 0, 1, 2, 3, 4, 5, and the summation is mean you plus them together. When you put n equal to 0, you would get 1, right? And then put n equal to 1, minus 1 to the power 1 is equal to minus 1, so you've got minus side there. X to the power 2 divided by 2 factorial. Put n equal to 2, minus 1 to the power 2 is equal to 1, so you've got positive there. And then put n equal to 2 again, you've got x to the power 4 divided by 4 factorial. And then so on. Put n equal to 3 and 4 and 5. Okay, so you get a summation like that. And if you have sin x, you would get summation n is equal to 0 to infinity again, minus 1 to the power n times x to the power 2n plus 1 divided by 2n plus 1 factorial, which is equal to, if you put n equal to 0 there, you would get 1 there. 0 there, you would get x. Okay, 0 there, 1 factorial, which is equal to 1. So the first term you would get x. Now you put n to 1, you've got minus there. Okay? N equal to 1, you get x to the power 3 divided by 3 factorial. Right? And then you put n equal to 2, minus 1 to the power 2 equal to plus 1. You got plus there, and then you put 2 there to the power 5, right? So you get x to the power 5 divided by 5 factorial. So the reason why I got to tell you this, because when we do differential equation, when we solve for the solution, then you would end up with the summation of some terms like this, and then you've got to conclude that for the final, what would be the function that you get, instead of put it as a summation like this. Okay? But if, for example, if you would get something like this, then at the end you would say, okay, you've got exponential of x, something like that. Now you would see cos hyperbolic x. Okay, which is equal to 1 plus x squared by 2 factorial plus x to the power 4 by divided by 4 factorial sine hyperbolic x. There's so many that you have to know. But sometimes you might end up with some function that you wouldn't know what is it. If in that case, if we can't arrange it in terms of any function, then you can put it as the power series like this. Okay? echelon 1 plus x, if in the power series form, you would get plus x to the power 3 divided by n equal to 1 x, n equal to 2 minus x over 2, n equal to 3 or plus 3. Okay. For the summation itself, for example, if you have the one function in the form of power series plus another function in the power series form, when you do plus minus, you can use the property of plus itself. For example, I said that if I have fx is equal to summation and gx is equal to summation bn, and these two functions is converged at any x value. Find the summation of fx and gx. Okay, the way that we do equal to summation n equal to 0 to infinity. So the way that we plot these two terms, b and n, just the constant. So if you take a look at this, the limit itself is start from n equal to 0 to infinity for both terms. And then both terms have the function of x to the power n. When you do the summation, you can do this way. Right? I mean, if someone don't understand the things that you can do is just that you can distribute each term there and then plus just couple terms of that, and then you would see the trends of it. Okay, for example, to put n equal to 0, you would get a0 plus a1x plus a2x squared for the first one, right? And then plus the second one is b0 plus b1x plus b2x squared plus until infinity. And the way you see, you have b0 and a0 and b0 there, right? So these two terms, you can put them together. You would get a0 plus b0. And the term a1x and b1x, because both terms has x the same, so you can put them together, so that's why you get a1 plus b1x. And the other term, you just do the same, and so on. So with this one, the meaning of this is just the summation n equal to 0 to infinity an plus bn x to the power n, right? So which is the same meaning as that one. Okay, so when you take a look at this and then you just don't understand what is it, the way that you can do is just distribute each term just like this, and then you do plus as you learned before, and then you rearrange the term and then put it back as the summation form. So you should be able to do this because later on you're going to do something like this all the time. And the thing is that why I can do this, because whenever you are going to do the summation, you got to be careful about the limits of n. If n start at the same place, then you can do like this. But if one, start from n equal to 2 to infinity and the other is n equal to 0 to infinity, you just can't sum it right away. You got to make the limit start at the same point first, and then the summation of the rest of the term. Okay?